All right, here we go. Hopefully that day off did some kind of got some kind of positive movement out of you guys. So here we go. There are 4 concurrent lines in a triangle. 4. Quiz on Monday. Quiz on Monday. I'll start talking about the quiz as I go through this chart. 4 concurrent lines in a triangle. 1 concurrent line. Name it. 5. Okay, I can. Perpendicular bisectors are all concurrent. Make sure you have an idea of what they look like. Perpendicular bisectors. Point of concurrency. Where do they all meet in the triangle? Here you go. 11. Circumcenter. And if I say point J is the circumcenter of this triangle, what are you going to know about point J? What's so special about it? 5. It is equidistant from the vertices. So whatever line segments are connecting the circumcenter and the vertices, those 3 are congruent. Do not be surprised if I have you graph a triangle on Monday and ask for where the circumcenter is. Okay, where the circumcenter is. So you have to graph at least 2 perpendicular bisectors and tell me where they intersect. All right, name another concurrent line in a triangle. Here we go. 3. The angle bisectors, yes. I'm starting to find out this is one people are not too comfortable with as far as the homework goes. They all intersect at the 27. 21, where they all intersect? In center. So if you're looking at for example, I may get asked this for homework. G is the in-center. G is the in-center, meaning all 3 lines that go through G are what? BD, if they were lines anyway, all of them would be what? This is a bad example. Let me do another one. Here you go. So H is the in-center, meaning all these lines, BF, CD, and AG that go through point H, the in-center, all have to be what? No, see, we're not understanding it. They're not congruent. They're not congruent. Stop. Everyone just stop. You're just yelling out stuff, and hopefully it sticks. H is the in-center, meaning what has to be FB, CD, and AG? They have to be angle bisectors. Okay? They have to be angle bisectors if that's the in-center. All right, what is so special about that in-center then? 6. Correct. Equidistant from the sides. All right, we're all good there? All right, name another one. Here we go. Name another concurrent line. 30? Altitude. Are you able to identify an altitude and draw one on your own in a triangle? Where does it have to start? And where does it have to be drawn to? Opposite side, but where specifically? Where it makes this line segment perpendicular to the opposite side. Okay, they all intersect at the 13. Okay, thank you. 20, we don't have a 28. How about 2? Okay, we're on fire today. How about 18? Where do the altitudes intersect? Orthocenter. You do not need to know a special fact, but you do need Monday to, if I give you a right triangle specifically, where does the orthocenter land on a right triangle? Remember, altitude, altitude. They intersect right there. There's your orthocenter. So we're the intersection of the legs. So legs intersection. What about an acute triangle? Somewhere inside. And what about obtuse? Outside. Don't be surprised. Hey, maybe I'll have you graph a triangle and it ends up being right. Where's the orthocenter? Give me the point of the orthocenter. And the big one we're forgetting here, not forgetting, we just haven't got to yet. The fourth and final line that is concurrent. 5, median. Are you able to identify and draw a median? Where's the median start? And what about where's this got to be drawn to? Midpoint of the opposite side. Boom, boom. Draw all of them in. They intersect at the 1. Centroid. That's a big one on Monday's quiz. We can do a lot of algebra with centroid because of the fact you know about it, which is 3. 2 to 1. Okay, 2 to 1. All right, any questions about that? So the quiz will cover it. Now on the quiz on Monday, I could do centroid. There's centroid algebra problems. I could just come out and say the intersection of the angle bisectors is called the what? And you got to fill in the blank with the correct word. I could say the point that is equidistant from the vertices in a triangle is called the blank. Okay? The point that breaks a median up into a ratio of 2 to 1 is called the blank. Okay, so be prepared for that. All right, I'm not going to have you guys write out a definition, but you could fill in the blank with the correct word. Homework, here we go. What do you got on the homework? Anything we got to finish cleaning up here before you see it on Monday again? Logan? Okay. Kind of went over a little part of this when I was going over the chart. H is the in-center. We said all these line segments, AG, CD, and FB are all what? These are all angle bisectors. Does everyone understand why? Because that's the in-center. That's how the in-center is formed by the angle bisectors. So I know an angle bisector, if that's 30, what's got to be next to it if this is an angle bisector? 30. If that's 28, what's got to be next to it? 28. I don't know the degree measures here, but at least I know they are congruent to each other because they're angle bisectors. How many degrees in a triangle? 180. So I can say 180 minus the 230s minus the 228s. And then whatever is left over for this angle here, I can divide by 2 and get angle HAC. Questions? Other questions? Go in. Yep. This 13 right here? Okay. Well, we know now that they're angle bisectors, right? So if that's 30, this is 30? Because we had to find what? DHG. Okay. Can you find that missing angle right now in this triangle? That's going to be 60, 180 degrees in a triangle. Same thing over here. That's 30, that's 90. This has to be 60. Total of 120. Okay? In-center, angle bisectors, equidistant from the sides. Other questions? Going. Yep. BD. Yep. I have no information right now to find BD. I have none. But I do know HD is congruent to, what other segments are HD congruent to? If this is an in-center, think about the rule for in-center. HF, stop right there. I can find HF. How can I find HF? It's part of a right triangle where I know a leg is 24 and the hypotenuse is 25. So I can say x squared plus 24 squared equals 25 squared. And I believe you get 7 out of that. All right, that's 7. That means HD is 7. Now you tell me, can I find DB? This is part of a right triangle. How many sides do you know of this right triangle now? 2. So I could say 7 squared plus x squared equals 11 squared. And then I find BD. And again, yeah, we could see something similar to it. Yep.
So on the test, what's total?
I'll have rounding directions if I need it. I'll have rounding directions. Jenna. Okay, same thing as previous one. G's the incenter, right? So I know based on the definition that it's equidistant from the sides, GD is congruent to GE is congruent to FG. I am looking for EG, which really I don't have enough information, but if I can find FG, those two are congruent. They're the same value. I can find FG. Again, it is part of a right triangle where I know the one leg is 12. The other one is FG, which I'm trying to find, and that's equal to 13 squared. Okay? Anything else we want to cover? Anything questions about the quiz on Monday? What I'm about to go over is also on the quiz. But anything as far as the vocabulary goes. Okay, let me see what you did. You're going to need a calculator for today without a doubt. If you have that triangle graphed, please find the midpoint of side BC, side BC. Find the midpoint of side BC for me, please. Only BC. Okay, what did you find for point BC? What was the midpoint of B and C? 21, what was the midpoint? 3.53. I'd like you guys to, as best as your ability, graph that point, 3.53, and call it point D for me. And draw in line segment AD after you do that. Please draw in line segment AD. All right. What did you just graph in? What's AD called at this point? What's it called? Median, correct. And where all three medians intersect is called the what? Centroid. Here's what we're going to do today. Try to do today. I do not want you to graph in the other two medians and tell me where they intersect. I just want to use this median and figure out where the centroid has to be algebraically. Okay? So I don't want to do the whole intersection thing. What I want to do is algebraically, is there a way that we can find out where this point, this centroid is? Okay? Review with me the centroid fact. It does break the median up into a ratio of what? 2 to 1. So we can start there. So at least I know wherever that point's going to be, it breaks it up into a ratio of 2 to 1. So think about this. If I'm going to find a point that breaks it up into 2 to 1, how many equal pieces would it make sense to break this median up into? Everyone agree with 3 equal parts? Yeah. So let's try to do that. Let's see if we can break median AD up into 3 equal parts. So what I did off to the side, and I don't want you to do this, is I drew that median out off to the side. So I want to show you exactly what's going on. So I got median AD, and you said we're going to break it up into how many equal parts? If I eyeball it, 3 equal parts up there. Everyone agree? I want the point that breaks it up into 2 to 1. That's the centroid. So do I want that point? Do I want that point? If that's A and that's D, do I want that point? Think about this, 2 to 1. You give me that point, I got 1 to 2 there, right? 1 congruent piece to 2. I don't want that one. I want 2 to 1. So now I want that one right there. That will be the centroid. Does everyone see the 2 to 1 right now? 2 equal pieces to 1 equal piece. We all good? All right, so that's our goal right now. Find that point on AD. Here's how we're going to do it. We're going to first go to the x-axis. How many units on the x-axis am I traveling from A to D? From A to D, how many units on the x-axis am I traveling? I'm traveling 8.5 total units. We all in agreement there. Can we find that? From A to D on the x-axis, I count 8.5 units. And you guys told me, how many equal pieces do we have to break this segment up into? 3. So guess what? We're going to take that x-axis distance and break it up into 3 equal parts. So I'm going to take my 8.5 and divide it by 3. All right. What'd you get? About 2.83 repeating, right? So here's what you just found. 2.83, I get to that point. Another 2.83, I get to that point. And then I finish off with another 2.83, and I'm at the end. So how many times do I want to go 2.83 on the x-axis to reach my centroid point? Twice. So that's why I say take 2, multiply it by 2.83. Or you can just add it again. It's up to you. So I'm taking 2. Everyone see why I got to go 2.83 twice? Because I don't want that point. I want this point right here. So how many total units on the x-axis do I have to go to reach the centroid? 5.66. So I have to go 5.66 total units on the x-axis from what starting point? Where did we start all this from? Point A, which is what x-coordinate? What was the x-coordinate for A? Just the x-coordinate. -5. So from -5 on the x-axis, you have to go 5.66 units to get to the centroid. Where do you end up on the, I know it's not the cleanest one, the first one, but where do you end up? 0.66, which I think as a fraction is 2/3. I don't care which one you keep. So that's where I end up on the x-axis to get to the centroid. All that we're doing again, but now we're going on the y-axis. Okay, we're going to do all this again to see where we get to on the y-axis. So here we go. First question. On the y-axis, this is going to be a little cleaner. On the y-axis, how many units do I have to travel to get to point D? I'm going from 0 to 3, so how many units is that? 3 units. 3 total units, and you're dividing it up into how many equal pieces again? 3. So I'm going to take that 3 units, divide it by 3 equal parts, and I end up with 1. Again, let me show you on my diagram what that 1 represents. Ready? Up 1. I get to the first point. Up 1 again. I get to the second point. Up 1 for a third and final time. I'm at the end, point D. That's what I'm doing. Do I just want to go 1 unit, though? Remember, that was my point. So how many total units do I want to go? 2. So I just take 2 times that 1. That tells me you got to go 2 units in total. Two units from what starting point? Where do we start this journey? On the y-axis. Where do we start on the y-axis? 0, correct? We started at 0. So from 0, I'm going to go up 2. And what's my y-coordinate for the centroid? 2. So the centroid is at what was the x-coordinate? 2/3 or 0.66, comma 2. That's where the centroid will be. 2/3, 2. That's the point. That'll be 2 to 1. And the first one's brutal. I know, first one's brutal. But once we start getting the hang of it, I think you won't mind it. Question, ask away now. Questions on anything I did up here? Because now it's going to be, can we do this for any ratio? Do I have to do 2 to 1? And the answer is no. We can do any ratio we want. Go ahead, Mike. How do you know you're going up exactly 0.66?
No, to the right.
I know, but how do you know that that's exactly 0.66? Might be 0.7. Might be 0.60. See my point?
Yeah.
Literally?
No, for the Y.
No, I know what you're saying. You're saying I'm going over 0.66, right?
Yeah.
But how do you know that's 0.66 exactly? Okay, that's my question. All right, that's why I needed to find the y-coordinate. Okay, because it may have been slightly below 2, slightly above 1 or 2. I don't know. Okay, everyone all right? Anything else you want to ask here? Yep. Which the top? Well, this 3 represents because I'm going 1, 2, 3 units to get to the y-coordinate of D. The 3 on the bottom is because I am splitting it up into 3 equal parts. Okay? Others here. Because no more graphing. No more graphing. I want to see if we can do this just algebraically. All right, I got A and B, -3, -4, and B's 2, 0. Now I want you to cut it up into a ratio of 2 to 3. Where's that point that will cut it up into a ratio of 2 to 3? So just a quick visual for this one, A, B. I want to find the point that cuts this line segment into 2 congruent segments on the left, 3 congruent segments on the right. So how many pieces total am I going to break it up into? How many total pieces should I break it up into? 2 on the left, 3 on the right. 5. So just to give you a visual, 1, 2, 3, 4. 5 equal parts. Yep, 5 equal pieces. Which point do I want? 2 to 3. Do I want that point? Nope, that's 1 to 4. Do I want that point? There we go. 2 equal parts to 3. So that's the point I want. Let's go x-axis first. X-axis. You're starting from A going to B. So from -3 to 2. Think about the x-axis right now. From -3 to 2, how many total units are you going? 3 for 3. 17. How many total units? 5 total units. Everyone agrees? 5 total units, and you told me to split that up into equal parts of what? 5? So every time I go to one of these points, how many units are you moving on the x-axis? 1 unit. 1 unit. 1 unit. 1 unit to get to every point here. All right, but I just don't want to go 1 unit. How many do I need to go? How many do I need to go to get to this point? 2. Yep. And if you're starting to figure it out, yes, it's always the first number in the ratio. So 2 times 1 gives me 2, which tells me that's not my x coordinate. That tells me from my starting point, you need to go 2 units. All right, from my starting point, you need to go 2 units to get to the x coordinate. What was my starting point for this segment? On the x-axis. On the x-axis, what was my starting point? 7? -3. And if you start at -3 and you go 2 units to the right, where do you end up at on the x-axis? 12? Okay, stop. Everyone stop. You're at -3. Where do I end up? There we go. Everybody good? -1. There's your x coordinate. It's not easy until you start picking it up. All right, y-axis now. Y coordinate. -4 to 0. -4. Total amount, total units you have to go. 18 total units. 4 total units. And you're still dividing that distance of 4 by what? 5, because you got to go 2 to 3, 5 equal parts. So that tells me every time you're going to go up now, every time you're going to go up, it's going to be how many units? 0.8. So 0.8, 0.8, 0.8, all the way up every time. Okay, how many times do I have to go 0.8 though to get to my partition point? 2, so 2 times 0.8, or 0.8 plus 0.8, total of 1. What? What do you mean 3? Why isn't it 3? It would be 3 if I started from point B. Okay, but since it's, and this is good directions too. See how it says directed line segment AB? That means A to B. If I went B to A, yes, you'd multiply it by 3 instead. All right, so the 1.6, a lot of rookie mistakes. They stop at this point and say coordinate is 1.6. That's just the total units you go from the starting point. What y coordinate did we start at? 24? 2? Nope. 16. What y coordinate did we start at? We started at -4, and I'm going to add 1.6 to figure out where I end up. And what do we end up with? -2.4. So the point would be -1, comma, -2.4. And what we're doing is a process called partitioning, cutting the line segment up into so many equal parts. Okay, that's what this is called, partitioning. Anything you want to ask here? Okay, I'm going to do this next one with you, see if anybody figures out what's a little bit different about this, and then you'll do example 4 on your own. Four to 1 now. 4 to 1. Still cutting it up into how many equal parts? 5, but now I need... Do I need that one? That one? That one? There it is. That's the one I need now, is that point at the end. 4 to 1. All right, x coordinate first. Okay, everybody on the x-axis with me. -2 to 2. How many steps are you walking? -2 to 2. 4 steps total. Got to divide those 4 steps evenly by 5 for a total of 0.8. All right, now here's the clincher. How many times do you have to go 0.8 on the x-axis? Right? 0.8, 0.8, 0.8, 0.8, 4 times. So that's a total of, that's not where you end up. That's not where you end up. That's telling you how many you got to go. And what was my starting x coordinate? 12. Where did I start on the x-axis? So -2, and I'm going to go 3.2 units to my right. And I end up where on the x-axis? I end up at 2.2 point. Yeah, 1.2. I don't know why this got so small on me. All right, y coordinate now. Let's see anything changes. 5 to -3. 5 to -3. 8 units. And I got some people saying -8 too. Either one's correct. I'll show you why at the end of this problem I like to say -8. Why are we attaching the negative to it, by the way? Because you're going down. Okay? Every other problem we've done so far, the y coordinate, we've always gone up on the y-axis, but now we're going down, so I'm going to keep it -8. I'll show you why that's helpful at the end. So that -8, we're still dividing by how many equal parts? 5. So we should end up at -0.6. If I'm looking at the right problem, yes, you're correct, -1.6. I was looking at the next one. Okay. So again, -1.6, -1.6. How many times am I going -1.6? 4 times still. So in total, I'm going -6.4. Now, this is why I think it's helpful to put it negative at the beginning. Because remember, all the time here, I've been adding what I'm going by. If you look back at the previous examples, I'm always adding. But you can't add anymore. Because you should not have anything bigger than 5. Does everyone see why? Because you're traveling down on the y-axis. So you shouldn't be getting like 7, 8, 9, 10. That's impossible. That's not even on the line. Okay, so that's why I like to keep it negative, because that reminds me right now, where did I start on the x-axis, on the y-axis again? 5, right? Now you don't want to add it. You want to subtract it because you're going down, and you don't have to worry about that if you make it negative from the beginning. So where's my final y coordinate? -1 point, whoa. -1.4, yeah. -1.2, -1.4 is that partition point. Okay, now it's time to do one on your own here. Take AB, directed line segment AB. So from A to B, you're going 3 to 7. How many equal parts? How many equal parts? 10. Why is it getting? Oh, that's why. How's this one going? Negative 0.2, 2.2. How's it look? Before I get to the last one with you, this is what 2 of these will be on Monday's quiz, and it's just as straightforward as this one. Here's 2 points, break it up into this ratio. All right, I'm not going to trick anybody with anything. All right, it's just very 2 problems, straightforward. Partition these 2 points into 2 to 3, 3 to 5, whatever it is. All good? All right, last one, which is take AB now, and how about this one? Partition into a ratio of 1 to 1. And I just gave this to you to see if anybody wanted to say anything here. Because you could still do partitions, break it up into how many equal parts? Say that again to yourself. We're going to break this line segment up into 2 equal parts. 1 to 1 is just asking to find the, yeah, that's it. Now, can you still do partitions? Absolutely. What we did today, yep. Divide by 2, multiply by 1, add it on at the end. But again, 1 to 1 is just, hey, you want to divide it into 2 congruent parts, you find the midpoint. Questions from you guys there? Okay. Again, 2 of these will be on there. You guys know the new homework assignment tonight, which is just the following pages, I believe, in the packet. Nothing's out of the book tonight. I am checking it on Monday, and then we'll take the quiz right after.